Hello, Cougars. It's Mrs. Belatesh again. And I want to do just a quick little review. Last time we used a thermometer, and when we put the red bulb into cold water, the liquid contracted and it went down the tube. When we put the red bulb in hot water, the liquid expanded and moved up the tube. And then we also saw what happened when we put a bottle with a stopper and a tube under a heat lamp. Over time, the water got hotter and it expanded and pushed its way up the tube. So it's not just water that expands when it gets hot. It's also air. So I have a balloon on this bottle and there's air inside this bottle. And right now the balloon is not blown up. It's very flat. But when I put the bottle in hot water, slowly, let's see if you can see it a little closer, the balloon is expanding. Before, the balloon was completely flat. But now the balloon is slowly expanding. And I'm not adding any more matter to it. I'm not adding any more air. Just the air that's inside the bottle, because it's hot, is expanding. Okay, so now you can see, oh, look at that. Now the balloon, the air inside has gotten so much more energetic and expanded that it has actually filled up the balloon, and now the balloon will stand up. Now I'm going to take my bottle and I'm going to put it in ice water. Here's some ice water. Now look what happens. Oh, immediately the bottle collapsed. The balloon collapsed. And the air is contracting. Now the balloon is flat again. And it's the same amount of matter, the same amount of air, but this time it is taking up less space. Last week, you guys got to use the thermometer and the bottle and pipe system. Now, some people have this little gizmo in their kit, and if you have this, it's your lucky day. You're going to use it this week. What you also need is a transparent cup with just room temperature water, not hot, not cold, just water that comes right out of the sink. And then you need some hot water, and I'm going to put some red food coloring in the water. And now what I'm going to do is I'm going to pour some of this water into this little vial. And this is hot water. And now what I'm going to do is I'm going to put this vial into the water. Hold on to it. We don't want it to float away. So I'm going to hold it up so you can see better, and I'm going to put the vial into the water. What do you see happening with the red hot water? Well, it's rising to the top. It did not go throughout the entire glass of water. It has floated to the top. Okay, now I'm going to do the same exact experiment, but this time, instead of having hot water, I have cold water in my vial. So I'm going to put my vial of cold water into the cup. Is the cold water floating to the top? Is it sinking to the bottom? Or is it pretty much staying inside the vial? Cold water is heavy. It is denser. It is slightly thicker than hot water. Hot water is lighter. It's a little bit more spread out. It will float on top of cold water. And that's what happened with these two experiments. And you can still see the red water is still floating on top of the room temperature water. So we have these two experiments. Hot things rise because they're less dense. They're not as heavy. Cold things sink because they are heavier. Cougars, please take out your science notebook and please put this into the next page, sinking and floating water. So you're going to glue that page into your next science notebook page. And number 1, it says, draw a picture of what happened when you lowered a vial of hot water into a cup of room temperature water. So this is the picture that I drew. I used red colored water, and I showed an arrow showing that the water left the vial and went to the top of the water and was floating there. Number 2, draw a picture of what happened when you lowered a vial of cold water into a cup of room temperature water. And I had colored my water green, and so the cold water stayed in the vial, although some did come out and sink to the bottom of the cup. Okay? Now, at the bottom it says, which water was more dense than room temperature water? Density means like heavier, thicker, more tightly packed. So which one fell to the bottom? The cold water. Which water was less dense? So if more dense means heavier, less dense means lighter. So it will float. So which one floated? The hot water. Which is more dense? Hot water or cold water? Cold water. Hey there, Cougars, it's Mrs. Belatash, and I'm outside and I have this thing called a solar tube. It's just a really, really thin black plastic bag. And right now it's empty. Well, it has a little bit of air in it. And I'm going to just fill it up with air, and then I'm going to show you what happens with it. And the way I fill it up with air is I just open it up and let the air go through. Okay, now I have filled up the bag with air. It's not really, really tight, but it's filled up. And now I'm going to tie a string to it, and I'm going to put it out in the sun. Now the sun is going to heat up the bag. First of all, the bag is black, so it will absorb the heat, and the light that hits it will be transformed into heat. So now we're going to see what happens when this bag goes into the sunlight. Okay, I've now moved into the sunlight, and I've got my bag, and I'm just going to let it absorb the heat from the sun. Now right now you'll notice that the bag is a little floppy. It's not really full. But as the sun heats up the air inside the bag, the air inside is going to is getting more energetic, and it's going to take up more space. And pretty soon that bag is going to be really tight because the air is expanding. The bag is getting fuller and fuller of air. And as the air gets heated up, it gets lighter. It gets less dense. And my bag is starting to float. The sun's energy heats up the air inside the bag. The air gets hot and it expands. And as a result, it floats. I did not put any helium in this bag. This is just regular air that is being heated up and expanding by the sun. There it goes, floating up. The power of the sun. All right, Cougars, I hope you had fun watching that solar tube. Just plain old air gets hot, expands, and becomes lighter. Hot things rise and cold things sink. Hot things are less dense, cold things are more dense. Pretty interesting. See you next week, guys.